Okay, I hope I'm audible to all my students who are attending this particular lecture for the Intermediate Microeconomics Part 2 course. Uh, in this particular lecture, I'm going to start with the discussion of the 2024 question paper, which has come up at Delhi University for the Intermediate Microeconomics Part 2 course. And this is for all those students who are pursuing BA Honors Economics from University of Delhi. I hope all the students can see the question paper on your screens. Okay, so in this particular lecture, I'm going to start with the discussion of question 1. Okay, so let's quickly start with the discussion of this particular past year question paper. So let's quickly solve part A first of question number 1. Suppose a monopolist's demand for the product is given by 200 minus 2q plus square root of A. This is the demand function facing the monopolist. Q is the quantity of the product. A denotes the total advertising expenditure. So that means the demand of the monopolist depends upon the quantity. The price charged by the monopolist depends upon the quantity as well as the level of total advertising expenditure. If the monopolist is producing at a constant marginal cost of 4 rupees, how much quantity will he sell at equilibrium and what is the optimum level of advertising expenditure? Also check for second order conditions. So we have to do the profit maximizing exercise of the monopolist. And we need to choose quantity Q and advertising expenditure A to maximize the profit of the monopolist, where profit is total revenue minus total cost faced by the monopolist. And using second order conditions, we need to show that the profit is maximum. So let's come to the whiteboard to solve this. Okay, so I hope students can now see the whiteboard. I'm just writing the main heading for completeness. We are looking at Delhi University, exam 2024 for Intermediate Microeconomics Part 2 course. Intermediate Microeconomics Part 2 course. And this is for students who are pursuing economics honors from University of Delhi. Let's look at question number 1, part A. I'm quickly writing the piece of information given to us. We are given that the demand facing the monopolist is PQA, which is 200 minus 2Q plus square root of A, where Q denotes the quantity of the product. A denotes the level of advertising expenditure. Level of advertising expenditure. Okay. And we are given that the marginal cost faced by the monopolist is rupees 4. So let's define the profit of the monopolist. So the profit of the monopolist is total revenue minus total cost. Total revenue is price times quantity minus what's the total cost? It's the total variable cost. How do I find the total variable cost? The marginal cost times quantity. 4 rupees is the marginal cost. If I multiply it by quantity, I get the variable costs. Plus the fixed cost of the monopolist is the level of advertising expenditure. Remember, guys, advertising expenditure is a fixed cost. Okay, it's not a variable cost because advertising expenditure once incurred, you can't recover it. It's fixed, irrespective of the level of quantity you produce. So my total cost is 4Q plus A, where A denotes the fixed cost of the monopolist, which is the nothing but the level of advertising expenditure. 4Q is the variable cost, which is marginal cost times quantity. So I can now elaborate this. What is my P? This whole thing is P. 200 minus 2Q plus square root of A. This is my P times Q minus, if I open up the brackets, this is minus 4Q minus A. So I can write profit of the monopolist is 200Q minus 2Q square plus square root of AQ minus 4Q minus A. And which I can further simplify. 200Q minus 4Q is 196Q minus 2Q square plus square root of AQ minus A. So now I can erase this initial portion off and I can write what is the objective. Objective is to maximize profit of the monopolist, which is from the bottom it is what? If I write this clearly, this is 196Q minus 2Q square plus square root of AQ minus A. So let me erase all this off now. And what do we need to choose? The monopolist needs to choose Q and A in order to maximize its profits. So we look at the first order condition. First, we differentiate with respect to Q. So del pi m by del Q equal to 0. Now, if I differentiate the profit function partially with respect to Q, what do I get? 196 minus 4Q plus square root of A equal to 0. Okay, so from this equation, I can write that 196 plus square root of A is equal to 4Q. Let's call this as equation number 1. And then I partially differentiate the profit function of the monopolist with respect to the level of advertising expenditure and I plug it equal to 0 because remember, the monopolist also needs to choose the level of advertising expenditure to maximize its profits. So del pi m by del A equal to 0 would mean if I differentiate this with respect to A, Q is constant. So it's square root of A. The derivative of square root of AQ is just, if I differentiate this with respect to A, what do I get? It's Q times 1 over 2 square root of A minus 1 equal to 0. So I get Q over 2 times square root of A is equal to 1. So I can get Q as 2 times square root of A. This is equation number 2. Okay. Now, all I have to do is solve equations 1 and 2 simultaneously. So, let's substitute the value of Q as 2 times square root of A here and solve for A. So, if I erase the initial portion off, erasing this part off, so I can write substituting equation 2 in equation 1 gives us what? 196 plus square root of A is equal to 4Q. But what is Q from second equation? 2 times square root of A. Now students can see we got everything in terms of A, so we are just going to solve for that. So I can write 196 plus square root of A is equal to 8 times square root of A. So this implies 196 is equal to 8 square root of A minus square root of A. So I get 196 as 7 square root of A. So I can write square root of A is 196 by 7, which comes out as, how much is 196 by 7? It comes out as 28. So this implies, what is my A? 28 square, which is 780. The optimum A star has come out as 784. Okay, and now let's find Q. How do I find Q? Remember from equation 2. Students must have noted down equation 2. Equation 2 was Q is equal to 2 times square root of A. Now plug in the value of A. What is A? 784. What is square root of 784? 28. And 28 times 2 is 56. This is my Q star. So I have got the values of Q star and A star. So I'm writing it here. My Q star has come out as 56 and my A star has come out as 784. Okay. And now, once we have found out the optimum quantity and the optimum level of advertising expenditure, let's also look at the second order conditions to check whether the profit is a maximum. So what were my first order conditions? If I erase all this off, I'm rewriting them. All the students must have written them down. I'm still rewriting them. The first order conditions were as follows. When I did del pi by del q equal to 0, I got 196 plus square root of a minus 4q equal to 0. Okay, this is what I had got, 196 plus square root of a minus 4q equal to 0. And once I did del pi by del a equal to 0, it gave me q over 2 times square root of a minus 1 equal to 0. Now let's figure out the second order. If I do the double derivatives now, del square pi by del q square. That means if I further differentiate this with respect to q, I get minus 4, which is negative. If I do del square pi by del a square, that's going to be q by 2 times minus half a to the power minus 3 by 2, which is minus q by 4a to the power 3 by 2, which is again negative. Okay, and if I do the cross second order partial derivative, for which I am erasing this initial portion of, if I do the cross derivative, which is del square pi over del q del a. How do I find this? Del pi by del q equation, I differentiate this with respect to a. That means this equation, which is this, I differentiate with respect to a partially. So what do I get? The derivative of square root of a is 1 over 2 square root of, which is positive. So my determinant, which is del square pi over del q square times del square pi by del a square minus del square pi by del q del a whole square. Remember from my intermediate mathematical methods for economics course, it's AC minus B square. Remember, if students who have taken up my mathematical methods for economics course in the previous semesters very well recall, this is my A, this is my C, and this is my B. The determinant is A into C minus B square. See, this is A, this is C, this is B whole square. And if you see, del square pi by del q square is negative. Del square pi by del a square is also negative, students can see. And this is positive. So negative into negative means this whole term is positive. So I can say my determinant is positive. That means it's a maximum. My profit is maximum. So I can write that the second order conditions are all met for profit maximizing. We have covered this in quite depth in our mathematical methods for economics. I can write since A is negative, C is negative, and AC minus B square is positive, therefore profit is maximum. At Q star equal to 56 and the level of advertising expenditure equal to 780. This is the complete answer for question 1, part A. Okay, now let's quickly go back to the question paper and let's now look at question 1, part B. So if I come back to the question paper now, let's look at part B. Suppose a small town has only one large pen factory and it is the only source of job in the town. The pen factory is planning to hire both high and low skilled workers from the town. So one factory, only one source of job, only one factory, but there are two kinds of workers, high skilled and low skilled. Its production function is given as follows. Q as a function of high skilled workers and low skilled workers is 12 ln LH plus 6 ln LL. ln denotes the natural log, we all know. Supply curves are as follows. Supply curves for two type of workers are as follows. This is the supply curve for high skilled worker. This is the supply curve for a low skilled worker. And we are given that the pens are selling in the market for 12 rupees. Pens is the final output produced by the factory. It sells for 12 rupees. Find the optimum level of each type of labor hired by the worker. That means we need to find the optimal values LH star and LL star. And we need to find the respective wages. We also need to calculate the firm's profit maximizing level of output and check for second order. So let's quickly come to the whiteboard to solve this. Okay. Let's look at question 1, part B. I'm quickly writing what is given to us. We are given that the production function for high skilled and low skilled is 12 ln LH plus 6 ln LL, where LH denotes the high skilled worker. I can write for clarity. High skilled worker, and LL denotes the low skilled worker. And we are given the production function. Okay, and we are given the supply curves. What are the supply curves? So WH as a function of LH is given to us as 2LH, and WL as a function of LL is LL. These are my supply curves for high skilled and low skilled. Price in the economy for pens is given by 12 rupees. So first of all, objective is to maximize the profit. What is the profit function, guys? So define the profit function as follows. Define the profit function as follows. Profit is total revenue minus total cost. Total revenue is price times quantity minus total cost is WH as a function of LH times LH. This is the total cost for hiring high skilled workers plus WL as a function of LL times L. I can write this is the total cost of hiring high skilled workers. This is the total cost of hiring low skilled workers. So my profit is nothing but, what is my P? P is 12. Q is how much? This whole big term is Q. So I can sub in the value 12 ln LH plus 6 ln LL. This is my Q minus WH as a function of LH is 2LH. So 2LH times LH plus WL as a function of LL is LL. LL times LL. So my profit function is 12 times 12 ln LH plus 6 ln LL minus 2LH square plus LL square. And now if I erase this particular part off, I can write here that the objective is to maximize profit, which is 12 into 12 ln H is 144 ln LH plus 12 into 6 is 72 times ln LL minus 2 LH square minus LL square. And we need to choose LH and LL in order to maximize the profit. We need to choose how much high skilled workers and how much low skilled workers to hire. Let's look at the derivatives now. Let's calculate the partial derivatives, first order conditions. First one, I just partially differentiate the profit function with respect to LH and I plug it equals. So if I partially differentiate, I get 144 over ln 144 over LH minus the derivative of 2 LH square is 4 LH. I plug this equal to 0. So I get 144 over LH is equal to 4 LH, which is 144 is equal to 4 LH square. So I get LH square as 144 by 4 is 36. So LH is 6. So I can write on the top, LH is come out as 6. Similarly, the second first order condition, I partially differentiate with respect to LL. So del pi over del LL equal to 0. So this will be 72 over LL minus 2 LL equal to 0. So I get 72 over LL is equal to 2 LL. So 72 is equal to 2 LL square. So I get LL square is equal to 36. So LL is 6. Remember, it can't be minus 6. Labor can't be negative. You have to hire positive labor on. So I can write on the top, LL has come out as 6. Now, once you have got these values, I can calculate the supplies, WH and WL. That's very simple. Just sub in the value. So if I erase all this off, my WH comes out as 2 times LH. LH is what? 6. So 2 into 6 is 12. WL will be WL. I can write is going to be LL. Let me write this clearly. WL is just LL. LL is nothing but 6. These are my supplies of high skilled and low skilled workers, respectively. What's the quantity? Q. Just put in the values here. 12 ln LH plus 6 ln LL. So this is 12 ln. How much is LH? 6 plus 6 ln. How much is LL? 6. So I can take ln 6 common. So I get 12 plus 6. So my answer for output is 18 ln 6. This is my Q star. So I can write all my answers. LH star 6, LL star 6, WH star 12, WL star 6, Q star 18 LNs. These are all my answers. And now students can work out the second order conditions to show it's a maximum. That's quite easy. What were the first order conditions we had got? Very simple. The first order conditions we had got were, so when I did del pi by del LH equal to 0, it gave me 144 over LH minus 4 LH equal to 0. And once I did del pi by del LL equal to 0, what did I get, guys? I got 72 over LL minus 2LL equal to 0. Now let's work out the second order partial derivative. So A, which is del square pi by del LH square, will we differentiate this again with respect to LH? What do I get if I differentiate it again? Let's work out what do we get once I differentiate this again. So I am differentiating with respect to LH only. So I get minus 144 over LH square minus 4, which is negative. C will be del square pi by del LL square. That means if I differentiate this partially again with respect to LL, so I get minus 72 over LL square minus 2, which is again negative. And then I find out the B term, which is del square pi over del LH del LL. That means, guys, this term I'm differentiating now with respect to LL. So it's 0 because there is no LL here. This is also LH, this is also LH. So the derivative of this term with respect to LL is 0. The cross partial derivative is 0. So what will the determinant be now? If I erase all this off on the top now, the determinant is AC minus B square. Okay. And you can clearly see that what's the sign of the determinant? What I'm more concerned about is the sign. A is negative. I have shown that. C is negative. I have shown that. B is 0. So A into C means negative into negative, which is positive. So I can say that since A is negative, C is negative, and determinant is positive. Therefore, LH star, LL star maximizes the profit. Maximizes the profit. This is my complete answer for question 1 part. Okay, so students, this is where I stop in this particular lecture. The objective of this lecture was to start the discussion of the intermediate microeconomics part 2 question paper for the Delhi University students. In the next lecture, I'm going to solve question 1 part C. So I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.